So this little video is just the last example in chapter 2 of your MATH6040. I was hoping we'd do it in class, but missed 2 lectures and I need to kind of move on, unfortunately. So maybe try it yourself before seeing this. Okay. So what we have here with Cramer's rule is if you've got a system of three simultaneous equations, excuse me, 3 unknowns, there is a way of finding just one of them. In this case, we're looking for Z. So what we have is probably the thing you should do is rewrite this as a matrix equation. So this, if I haven't got the numbers wrong, I actually don't know what this is here. I think it's a 3. You might have to fix it in your own notes. So this is 1x minus 2y 1z, 3x 2y minus 1z, minus 1x 3y 5z. So write it like that, x, y, z equal to minus 4, and as I said I'm going to go for 3 here, 0. And now this is in the form ax equal b. In theory you can multiply both sides by a inverse to solve it, but we haven't shown you how to find the inverse of the 3 by 3. So Cramer's rule is this little dz over d. Now the d is the easy bit. The d is the determinant this little matrix here, matrix of coefficients. So if d is equal to the determinant, we write determinant using these bars. 1 minus 2, 1, 3, 2, minus 1, minus 1, 3, 5. So writing that is how you say, I want the determinant of this 3 by 3 matrix. To calculate it, one way of doing it is write the first 2 columns again. 1, 3, minus 1, minus 2, 2, 3, and do right down diagonals minus left down diagonals. So right down diagonals, 1 multiplied by 2 multiplied by 5, minus 2 multiplied by minus 1 multiplied by minus 1, 1 multiplied by 3 multiplied by 3, and your left down diagonals then minus 2 by 3 by 5, 1 by minus 1 by 3, 1 by 2 by minus 1. And so let's see what we got. 1 by 2 is 2, so I'm doing the right down diagonals. 1 by 2 is 2 by 5 is 10. Minus 2 by minus 1 by minus 1. Now when you've got 3 minuses, minus by minus will be plus, the last will give you a minus. So certainly minus. And then 2 by 1 is 2 by 1 again is still 2, so it will be minus 2. 1 by 3 by 3 is 1 by 3 is 3 by 3 is 9. Now this is, it's important that this number here is 3. Okay, takeaway. So right down diagonals minus left down diagonals. So I have 1 by 2 by minus 1, that's minus 2. 1 by minus 1 by 3, that's minus 3. And minus 2 by 3 is minus 6. By 5 is minus 30. And so here you got, we have 10 plus 9 is 19, minus 2 is 17. Takeaway, this looks like minus 35 to me. And 17 minus 35 is 17 plus 35, I believe is 52. Now, the dz is pretty much the same thing, except the z coefficients, the 1 minus 1, 5, replaced with the constant coefficients minus 4, 3, 0, again assuming this is 3. So what dz is the determinant of the following matrix. So you just take the matrix coefficients and replace the z coefficients with the constants minus 4, 3, 0. So dz is the determinant of that matrix there, and you calculate it as before. You write the first 2 columns and do right down diagonals minus left down diagonals. So dz is equal to the determinant of this as we said, write the first two columns again, 1, 3, minus 1, minus 2, 2, 3. And we do right down diagonals minus left down diagonals. 1 by 2 by 0, minus 2 by 3 by minus 1, minus 4 by 3 by 3. The full length tree right down diagonals. Minus 2 by 3 by 0, 1 by 3 by 3, minus 4 by 2 by minus 1. So 1 by 2 is 2, but by 0, 2 by 0 is 0. Minus 2 by 3 is minus 6, by minus 1 is plus 6. Minus 4 by 3 is minus 12, by 3 is minus 36. Take away the left down diagonals. So the first one here, minus 2 by 3 is minus 6, but by 0 is 0. 1 by 3 by 3 is 9. And minus 4 by 2 is minus 8, by minus 1 is plus 8. And I have a feeling it's not going to work, but I think it's because of, well, the answer says short, it said equal to minus 1, but I'll kind of fix it at the end. I don't think there's any mess up here. No. So I got minus 30, minus 17, that's equal to minus 47. So you can fix your one in your copybook, but I'm reading this as a 3, perhaps it's an 8, I don't know. So we'll just say use Cramer's rule to find Z, and let's say that this is definitely equal to 3, because that makes the rest of what we're doing actually correct. So we get a funny old answer. I suspect it's probably an 8 knocking around instead of a 3. But a funny old answer, Z is dz over d, it'll be minus 47 over 52. Now we have Z is equal to dz over d. We calculated dz to be minus 47 over 52, and that can't be simplified. You're an engineer. If you want, you can use decimal approximations. I'd be dead against them. If you are using them, I would like to see 4 significant figures. So 4 significant figures, this is approximately minus 0.9038. But this, as far as I'm concerned, is better. You can use Cramer's rule to go off and find x, y, and z, but it's in my opinion, it's very long. And when you go to larger than 3 by 3, this gets very, very slow. Okay. Now, this worked example, by the way, is just a good one to look at. We could give you a matrix coefficients, that's the matrix coefficients here, give you the inverse, and then solve this. So what you'd have to do is write this as ax equal to b, and then do your stuff with a inverse. X would be a inverse times b, and we give you a inverse. So you just have to do that, y, that vector there, to find x, y, z. So that's everything for chapter 2.